Yeah, before starting the session, I would like to thank you, the organizers, especially Oliver, Andre, and Roxane, she's not there. So thank you for the opportunity. So my topic today is about Tekton's roles in continuous deployment and the DevSecOps compliance. Basically, I will be explaining more about a use case study which I have worked in for a client. So let me tell myself. So my name is Rahul Raj, and I have 10 plus years of experience in DevOps and cloud, and I'm one of the leading organizer in CNCF Riyadh community, Saudi Arabia. I came all the way along to Saudi Arabia, and one of the chapters in Trivandrum, that is in India. And I'm working as a lead consultant in Xebia. I worked in multiple companies like Accenture, EY, and HR Block. Also, I'm a corporate trainer, blogger, speaker, and I'll do multiple technical forums, blogs, and all. So, what are we trying to pull here? So you can see, I'll demonstrate how Tekton facilitate here for the continuous deployment and how the devs compliance work in. Second thing, I will show you a real case, real world case scenario that how it works for one of the banks, leading bank in Saudi Arabia, how we implemented it, and I will just go through a business study of how it impacted us and what are the lessons we have learned throughout the story. So first, will an introduction about Tekton. So I will cover up about, I'm not sure who all are new to Tekton, or if we want to brush up, it will be a good thing. Second, I'll be cover the case study. Third will be the impact analysis and the lessons learned. So talking about Tekton, introduction to Tekton, it's like Tekton is an open source tool. It's a Kubernetes on framework. It is working. You all know that the CRD things, how the CRD works in. So it's deployed inside the Kubernetes cluster. So it's an open source one, which is done by which is on Cloud Foundation is leading the thing. Okay. So it basically allows a CI/CD pipeline to run, and you can use this document for reference, tekton.dev.docs for implementing the things. So as I said, it's a complete CI/CD cloud native Kubernetes native technology which runs in CRT, and it will be ideally naturally compatible with Kubernetes things. And second advantage is it uses declarative pipeline. As we all know that we work in DevOps and cloud industry, writing some declarative pipeline in the YAML format is most compatible for us. So it works for the declarative pipeline. Third will be it is modular and reusable. We can write tasks for all the pipeline works. If we want to clone a Git repository, or if we want to do a build, just do a task and call it every time whenever you require. So it is so modular, and you can reuse the functions all the time. And one of the attractive thing is it does not need a CI/CD server. For example, if we are running CI/CD platform in Azure DevOps or Jenkins or GitLab, we definitely require some CI/CD server to run, agents or master slave technology to run. So since it is running on top of a Kubernetes cluster, it does not require a CI/CD server here. And it's open source. You know that CDF is hosting it, and it's a very wide variety community. So we'll get all the documents and the community support here. So Tekton is actually classified, the resource in Tekton is classified into pipelines, where we usually write the pipelines in structured format, where it will call each and every topics inside the pipeline. As I said earlier, in Tektons, it is split into tasks. So in pipelines, we will call all the tasks whenever we require. For example, if I want to run a complete pipeline, we will call the tasks one by one for doing the complete CI/CD technique. And how we trigger it, it comes in the triggering technique. So most of the developers who will do mostly it will be a code commit. When the code commit comes, it will trigger a pipeline, or when it comes tagging things, it will trigger a pipeline. So all those things are supporting by Tekton. And the pipeline runs is an instance what we run the pipeline, and we can check the logs. All those things will be covered inside the Tekton's pipeline runs. So here you can see a basic or kind of a stages how the Tekton pipelines running all the time. So first of all, we will do the git checkout. We will write everything as a module. So git checkout is a module which will do the git clone things where we can pass the parameters which will be compatible for all the projects. We can call the parameters as like a git clone URL, and it will do the SSH or HTTPS calls. And build and run unit test. You can integrate with any platforms like Java or .NET or anything, and you can integrate it with SaaS techniques, any SaaS tools like SonarQube we have tried it before, and Docker image building will be there. You can use Docker image building and push to any of the repository. So these are compatible with CI and CD. When it comes to CD, it will be configuration management where you want to deploy the servers and if you want to pass the secrets and parameters. And Dast is really compatible with that. You can use Strovie or any other tools. It will be easy to integrate. And the deployment part. So this will be the normal CI/CD pipeline of Tekton, how it will be work at basic Tekton pipeline. So here we go with the use case study, how we have implemented the Tekton for leading bank in Saudi Arabia. So here I will be presenting you the architecture, how it works, and what are the impacts and how we integrated with each and platform, and what are the key takeaways or the lessons we have learned from that. So here you can see the architecture diagram where we have integrated using a git push before running to the Tekton, what are the main challenge we have faced here is we were using Azure DevOps pipeline for all the CI/CD operation. So when it comes to Azure DevOps pipeline, one of the major challenge we faced was the agents or the background runners. For bank kind of infrastructure, the code is always on premise, or especially in Saudi Arabia, you know that the cloud is not there in anywhere in Saudi Arabia. So Saudi Arabian banks or everywhere, they depend every time on on-premise infrastructure because they don't want their code to go out of their country. Since you heard of the news that recently all the clouds are coming to Saudi Arabia, recently Google Cloud has started, AWS and Azure is coming on the way. So right now bank completely working in on-premise environment, and we are hosting everything on an agent, and agent server is deployed inside the bank premise. And what are the challenge we faced is triggering a build will always take a lot of time because every time a lot of builds are there in the queue, and we are getting very frustrated that builds are in queue and nothing is working out, and the number of agents we need to increase is having a very much limited one. So that one of the problem we can solve here. What we have done, like we already our source code is there inside the Git repository, and we used a webhook from Azure DevOps to pull the source code whenever say like we set out some trigger operations, like whenever a commit has taken care or whenever a git tag has been taken care, the pipeline will automatically trigger. So our Tekton pipeline, which will first do the git clone operation, that is a task. It will first do a git clone operation, and we are using some Java source code here. So we will do a Java build using Gradle, and Gradle is easy compatible with Tekton. And we'll do a JUnit test, which will give us the unit testing integration and the result, the coverage result. Then we integrated with SonarQube for the SaaS thing. So SonarQube result will be published in the SonarQube server. So that's we are calling with the SonarQube task. Then it will go to the building of image, which will be a Docker image building, and it will publish to the Quay repository. So for running all these stages, ideally the code should be shared among all these tasks. So we are using a Kubernetes native PVC as a workspace for the all integration, and the source code will be, or the sharing of the files will be shared through the PVC. So there the CI will take care. And comes to continuous deployment, we use multiple tasks for the deployment. One of the tasks we are using for the configuration management and the packaging, we are using Helm chart, which is easy to integrate with Tekton. And we are Argo CD compatible, that we are doing GitOps things. So Argo CD will get is synced, and when the code is getting changed, it will inform the Argo CD server, and it will get deployed easily. And we are using OpenShift, so Tekton pipelines and OpenShift and Quay is the more compatible field there. So it will be easily deployed to each and every namespace, production or dev or testing, whatever it is we require. So here it works. And all this configurations and parameters we are handling using config map, Kubernetes native secret handling, config map and Kubernetes secrets. So the impacts and the integration. So basically when I explain about the Tekton pipeline, so Tekton pipeline is something which is running inside the Kubernetes cluster, Kubernetes native pipeline thing, but integration is one of the challenges, because as you seen, like there are a lot of tools coming into the picture, right? So when we talk about the first integration, as I said, like Azure DevOps integration, which is one of the challenges we have, because we are hosting an Azure DevOps on-premise server. So we used to integrate it with Azure DevOps Git repository for the triggering things. HTTPS was not supporting for us since there was some blocking for the banking area. So we use SSH connections to trigger and pull the codes. You use webhook for the pushing things, and triggers. It will trigger when we tagging a particular source code. For example, if you want to deploy to the production, we will tag using _prod. And once a tag got generated, it will automatically start pulling the triggering the webhook, and it will start running the pipeline. And another integration was SonarQube, where we want to do the SAST, because security is one of the important thing we should take care. So the quality will be tested there in SonarQube, and we can able to do a gate technique there. So the Tekton pipeline will get failed if the SonarQube gate got failed. And the coverage, we will generate or grab the unit test result from the Tekton pipeline, and it will push into the SonarQube server. So the coverage result also being generating, and the integration is happening there. The Quay integration, as I said, like OpenShift, we are using for the integration of the source code, Docker images. So the container registry we are using Quay, and it will do so in Quay there is a technique for us for do the security scanning. So Quay will scan the Docker image, and there will be a pre-validation condition checking by Tekton whether the code needs to be securely completed and whether it needs to be deployed in the environment. So the pre-deployment condition we can able to write in the Tekton pipeline itself. And coming to the releases, so as I said, like earlier there was a bit slow in doing the Azure DevOps pipeline. Now once we migrated to Tekton pipeline, the releases are very faster, because something we need to finally put into Kubernetes cluster, which we already taking care by CI/CD pipeline. So code is already pushed to the Tekton pipeline, and it's completely handling inside a Kubernetes cluster. So there we leverage all our release pipeline speed and agility. And deployment is happening in the OpenShift clusters, and compliance is handled by each and every tool, and security credentials, everything is handled by Kubernetes native secrets, kube secrets. So key takeaways: one is the integration things. So as you've seen, like there are a lot of tools take part in the integration side. There are a lot of existing tools, pre-existing tools, because as what we have done in the Azure DevOps, we have an important thing, like we need to replicate the same thing in Tekton. So one of the thing which we need to deliver is the Tekton was able to completely replicate what we have done in the Azure DevOps pipeline. So it was easy to integrate all the tools. Second thing we achieved was the optimization of pipeline. We need to go with another agent for the source code building, and once everything is done, we need to come to the Kubernetes cluster side. So that pipeline things are optimized, because whenever a pipeline is running, it will automatically create a pod inside the cluster, and once the job is done, it will decommission the pod. So all those things were optimized and completely handling by the Kubernetes cluster, and it will increase our time. It means increasing our efficiency in building the doing the builds than Azure DevOps where we used previously, and the efficiency was also get increased. I'm not taking much time, because I know that already the session is going very late. Okay. Any other questions for this? Audience side? No. Okay. It's all good. So yeah, thank you.